Welcome back. Uh, Now we will study about database management system and different data structures. Now, before we straight away move to database management system and data structures, we will again have a look at different data models. We already know that what is a data model is the real conversion of real world geographic variation into discrete objects, and it represents the linkage between the real world domain of geographic data and its computer representation. Now, in the previous lectures we discussed about spatial data. It may be represented by a point, line, or an area, and a point can be represented as an entity with x and y coordinate. Likewise, a line like road may be represented by a series of x and y coordinates, and any area like a floodplain or a forest area or an agricultural area can be represented by a set of xy coordinates plus the label of that respective feature. So we can have the spatial data in the form of point, line, and area or the polygon, and which can be represented by x and y coordinates in point, in line, or in a area form. Now we also have non-spatial data, which is also called as attribute data. Is non-spatial data or attribute data is that qualifies the spatial data, not specified by its geometry alone. It doesn't give information. It qualifies the spatial data that this was the spatial data with x and y coordinate. Now these are the ancillary characteristics, ancillary data. It has these features. It has this number of things. It is characterized by these features. So we can qualify the spatial data with the help of non-spatial data or the attribute data. Now we know that this is polygon, this is arc, and this is point data. Each spatial feature has at the background a database which is in the form of a table. So the point data may have the information recorded in the form of tables. Likewise, the line feature might have the attribute data in the form of tables, and a polygon will also have an attribute data in the form of polygons, the data which qualifies the spatial data. So it has the qualification, extra qualifications of that spatial data is represented in the form of a tabulated data structure, which we call as and if that is maintained, we call that as database management system. Now in detail, we can say the database management system can be regarded as a tool for representing in a computer a real world oriented model of a set of data. This relatively high level representation or abstraction is referred to as a conceptual model, and the specific description in the database is referred to as schema or conceptual schema. Now there are many types of data structures, how a data can be structured. There are various ways of doing it, and the first among them is the hierarchical data. Now, hierarchical data model looks like a tree structure. It looks like a tree structure. There is a hierarchy of parent and child data segments. Like this is the parent and these are the child, and this is the parent now, and these are the child 1, 2, and 3. So you have to understand a college has departments, and it has infrastructure, and within the department we have courses, we have teachers, we have students, and in the course we have theory as well as practicals in the lab. So this is one way of representing the data in a database management system. Now another type of managing data in database management system is the network data structure. It's a simple network, and link and intersection record types may exist, as well as sets between them. So in each set, one record type is owner, like here you can see, and one or more record types are members. So how can we understand network data structure is that this is the project, this is project 1, this is project 2, and these will act as the owners. And in project 1 it may have its members from department A, from department B, as well as from department C. And project 2 may have its members from department B and department C. So this overall forms a network, and sometimes necessity arises to represent all the non-spatial data in the form, spatial as well as non-spatial data in the form of this data structure called as network data structure. Now the third one is relational data structure. It's a database based on relational model and was developed by E.F. Cord. Relational database allows definition of data structures, storage and retrieval operations, and integrity constraints. Now what are the properties? We have the relational tables, like this is one table and this is the second table, and in this is the same set of the data is recorded from the same set of students, but at different intervals of time or by two separate persons. Now the one person was assigned to have the data of age, sex and weight, and the another student was assigned to collect the data on blood group, but the students overall remain same. And how the students are uniquely defined? They are defined by student ID. Student ID will remain same and will not change. Now in these two tables, if we take this first table, here the student ID is the primary key, and the second key, these columns refer to the table 1, to the primary key column. So this is called as a foreign key. So on the basis of primary key and foreign key, we can merge these two tables into one based on the student ID, based on the primary key. This is the foreign key because it refers to the student ID, that is primary key in the table 1. Now what are the properties of relational tables? Values are atomic, each row is unique, column values are of same kind, the sequence of columns is insignificant. It doesn't matter how you put the the sequence of the columns. The sequence of rows is insignificant, meaning the same. The sequence doesn't matter much, and each column has a unique name. You can see each column has a unique name as age, sex and weight. So each row is unique, each column has a unique name, and the sequence is insignificant. Values are atomic. These are all the properties of relational